Welcome back to this video tutorial. We can continue with the syntax of printf statement. Okay, we have discussed about the first syntax, this particular usage of printf. Now consider this particular usage. That means inside the parenthesis, inside the code, specify the format string and putting a comma. After putting a comma, specify the argument list. Okay, the format string like %d, %c, %s, %f, etc. Okay, so for understanding this particular format, consider this particular program example like this. Inside this main, this statement actually meant for including the standard input output library in order to access the printf and scanf function. Basically the printf and scanf. Okay, and inside the main function, here we have the variable declaration statement. What I meant by this variable declaration, char ch equal to inside single quotes, here it specify the capital letter A. What's the meaning? While declaring a variable like this, here it is which ch as a variable of type character. So while declaring a variable like this, what will happen? Inside the memory, allot a particular amount of free space, particular bytes inside the memory, free bytes inside the memory, and labeled it as ch. Okay, so for a character type variable, in order to store a character in our memory space, it requires a single byte of space. So while declaring this ch as a character type variable, so transfer the control directly to our memory space, system memory, and there allot a free 1 byte of space there and labeled it as ch. Okay, here we can store the value represented here. Here capital letter A is assigned to this variable ch. That means the binary representation corresponding to the ASCII code of this capital A is stored here in this particular memory space, which is labeled as ch. And this ch is a character type variable, so here it actually allotted single byte of memory space. A character type variable require a single byte for storing the entire value in C language. Okay, so it here, this is the allotted 1 byte of space for storing the ASCII code corresponding to the uppercase letter A. Normally inside the memory, we have already learned that the machine or binary codes are stored in memory. For a character type value, the binary code corresponding to the ASCII code is stored here. Right? And next is an example. This is a type of variable, integer type variable, and the variable name is no. Okay, so there we want to store the value 10. While executing such variable declaration, what will happen? Directly transfer the control to memory space. There allot 2 consecutive free bytes of memory. For an integer type, it usually takes 2 consecutive memory space. There we can store the binary equivalent corresponding to this decimal 10. So while using 2 consecutive bytes, we have total 16 bits of information. So using this consecutive 16 bits of information, we can store the value 10 in its binary form. Right? So for next, the float type variable FLT. So transfer the control to memory, allot 4 consecutive free bytes for a floating type value. Okay, and labeled it as FLT, the name given here for that variable. Okay, then we can store the binary equivalent corresponding to this fractional number using this consecutive 4 free bytes allotted and labeled as FLT. And here these are the 2 consecutive space allotted for storing the value assigned to the variable no. Here 2 consecutive bytes are allotted because no is a type int. Okay, here ch is a type char, and usually a character take a single byte of memory space for storing its value. So here it allowed a 1 free byte space and is labeled as ch. Here we can store the binary format corresponding to the ASCII code of uppercase A. Okay, so for next type, double type value, the variable name is gbl and the value is like this. Okay, for storing this value, what we want to do, while declaring this dbl, directly transfer control to memory, allot total 8 consecutive bytes because it is of type double. Then using that 8 consecutive bytes and labeled for the first byte as gbl, and using that 8 consecutive bytes we can store the binary representation corresponding to this number assigned to this variable dbl. Right? Okay, now we want to display the values present in these variables using printf statement. How can we print the value using this printf statement? The syntax is printf inside the parenthesis and inside the quote to specify the formatting string, then specify the variable name. Okay, so printf inside the parenthesis, inside the quote, the character is, then specify the formatting string as %c here. Okay, and after closing this quotes and putting this comma, then specify the variable name. While executing this statement, what will happen? So it identifies that we are going to display a character type value because here the formatting string given it as %c. So we are going to display a single character. Okay, so the character available in which variable or which memory location? The character is available in a memory location which is labeled as ch. Okay, so this particular formatting string indicate the type of this value available in this particular memory location which is labeled as ch. Okay, there should exist a match between this type and the type of the value present in this particular variable. Right, so what will happen? Here it display the value available in this memory location which is labeled as ch. Here it is the capital letter A. Right, so for executing the second printf statement, what will happen? First display the statement up to this floating value is. Then for this particular formatting string %f, substitute a value from the memory location or from the variable which is represented like flt. So move to the memory and identify the location which is labeled as flt and fetch the value from these 4 consecutive bytes because flt is of type %f, floating point type. So consider these 4 consecutive bytes and display that floating point value using this printf statement. So instead of this formatting string %f, here it substitute the value from the memory which is labeled as flt. So here this flt actually indicate to these 4 consecutive bytes because flt is of type float. Right, next for displaying an integer value. So directly display the string integer value is, and for this particular formatting string it display the value from the memory location which is labeled as no. Okay, so transfer control to this location. This is the label no. And O is actually an integer type label, so consider these 2 consecutive bytes and collect the value from this location which is actually 10. So instead of this %d, here it substitute 10. So the result displayed is like integer value is 10. Okay, now this for displaying the double value. So while executing this printf statement, what will happen? Display double value is, and the for this particular formatting string %lf, %lf actually the string indicating formatting string indicating a double type value. So for this particular location, here it substitute value from the memory location which is labeled as DBL. Actually, DBL is a double type value. So consider the 8 consecutive bytes which is labeled using DBL and the fetch value from that location and substitute for this particular location. Okay, so this is the case of printf in order to display the value of arguments. Okay, while executing this, the output like this. Okay, so analyze this. What will happen? So while executing this printf statement, character is, instead of this percentage %c, here is substitute a value from a memory location which is labeled as ch. Okay, so ch is the label or the variable which hold the value a. So instead of this percentage %c, here it substitute value a. Next is printf float value is %f /n comma flt. So here instead of this %f, it substitute a value from the memory location which is labeled as flt. Right? Here flt is the variable of type float. So and here it is assigned with the value 10.234. So instead of this %f, here is substitute the value 10.234000. Okay, so total how many fractional values, digits we can represent it in floating point? Total 6 fractional digits we can represent it in floating point value. Okay, so the remaining portions are substituted with value 0. Next, for displaying the integer value, so displayed as integer value is, instead of this %d, here it substitute the value from the memory location or the variable no. So no is an integer type variable, so and is assigned with the value 150. So here it is, integer value is 150. Okay, and for displaying the double type value, the syntax is double value is %lf. Right? Instead of this lf, it assigned a value from the memory location which is labeled as dbl. dbl is a double type variable, so we need to consider the 8 consecutive bytes. Starting from the label dbl, we need to consider 8 consecutive bytes because dbl is a label of type double. So collect the value from that location. Here it is, the value 220.123456. So display that value instead of this LF. So this is the result of this operation. Okay, now we can make some modification, like instead of using separate printf statement, we can display like this. Character is %c /n ch. Okay, now we can put this statement here before this chord closing. Okay, /n, then display the next statement, float value is %f. Okay, then put a /n. Okay, again display integer value is %t. Okay, then put a /n. Again display double value is, then put %lf. Okay, then we can stop here, right? Put a comma, then represent ch comma. First we need to display the character, next we want to display float value. So for for substituting for this %f, here we can use the variable flt. Next we need to display the integer value. For substituting this %d, we can use the integer number no. from the variable LF. And for substituting this for this percentage LF, now we can substitute here DBL. Right? Now we can remove all these three statements. So simply execute this. Okay, the same result using a single printf. Character is, instead of this percentage D C, here it substitute the first value from after this comma. Here it substitute the value from this variable ch for this particular percentage C. And for this percentage F, it substitute the value from the second variable. Here it is FLT. Here there exists a format matching between this value from this variable and this format string. So without any error, it can substitute the value from FLT to this percentage F. So for the third, we need to display a percentage D integer type value. So here in the third position of variable, here we have NO. NO is actually an integer variable. It holds the integer value 10. So without any error, we can substitute here the integer value, because here exists the format matching between this variable and this format type. And the last one is LF, indicating double. For instead of this LF, percentage LF, here we can substitute the value from DBL. DBL is already a double type value. There also the format match exists between this LF with this variable DBL. So without any error, we can substitute the value from this variable to this LF position, percentage LF position. Okay. So this is the output. Okay. Now we can stop here the syntax of printf statement.